Alright, hey everybody. So I'm going to go over the assignment 2, the 8 Queens problem. So for this problem, as I said before in class, we have a chessboard of it's 8 by 8. And I'm going to put down 8 queens on the board in a way such that none of the queens will hit each other. So a queen in the classic chess game can go any number of spaces in the horizontal direction, vertical, and diagonal. So for example, if the queen is right here on the board, the queen can go as many spaces as she wants this way, this way, this way, and this way. So basically, I'll go over the method I use. I'm not going to go over the entire example because it will take too long, but this is what I used. So initially, we get our first input. So for test input 1, the user gave row 1, column 1. They wish to put a queen in that spot. Okay, so row 1, column 1, we put a queen over here. And notice, so this is, hopefully you can see a difference. This is a green box right here, and the blue boxes are the unsafe locations. So hopefully you can distinguish between that. They should have not used green and blue here, but it's okay. So anyway, so I put a queen down here, and you can see here the blue spots are marked. These are the unsafe locations. So no queen can go in these spots, because if that were the case, this queen would, be able to attack the other queen. So we can't put a queen anywhere else. So no other queen can go on this row or in this column or along this diagonal. So in my function, what I would do in my program, I would first call a function and pass in row 0. And I see that row 0, that's already sort of a fixed queen, because remember, the user in this case decided to put a queen in this row. So we skip that row. So we go to the next row. And what we do is in this row, I start from column 0, column J is 0, and I see where's my first, safe spot from left to right. So this is not a safe spot, neither is this. And I found my first safe spot to be right over here. So I'm going to go ahead and put a queen down here and mark the locations on the board that are unsafe, which we can see here, these are the unsafe spots now. So that means nothing else. These blue spots here, no queen can go here. So I marked them unsafe. So anyway, let's move on. So that's the next row done. So what I would do is, well, this row I'm not done processing just yet. So I would call recursively on this row. And once I put a queen down here, I put a queen there, I mark the spots unsafe, and then I would recursively call this function onto the next row. So if I had some row counter, I would always call the recursive function row counter +1 to go to the next row of this sort of board. So going to the next row, I would start at the first column, and this spot's unsafe, so I can't put a queen there. Unsafe here, unsafe, unsafe. So I use a loop basically to traverse this, and I find the first safe spots right here. So I'm going to put a queen down here and then mark the new unsafe locations on this board. So you can see here my new unsafe locations. So here's where I had an issue in my code, which I'll explain in a second. But over here, just before I move on, this diagonal marks the unsafe locations for this queen. But then this queen has this diagonal. So this guy right here is sort of, this spot here, is overlapping between two queens. So because of this queen and this queen, this spot is unsafe due to two different queens. So be careful when you unset spots on the board, which I'll go over once we get to that point in this example. So anyway, I put a queen down in this spot. I marked that I put a queen here. I marked the unsafe spots on my board. And then I recursively go to the next row. So on the next row now, I start from column 0. It's unsafe. This spot is safe. So I'm going to go ahead and put a queen down over here. And I marked new unsafe locations. And then I go on to the next row, because I put a queen down, so on to the next row, starting from column 0, unsafe, 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 my first safe spot, so I put a queen down over there. And now nothing is safe anymore, so I go to the next row, I see it's unsafe, unsafe, unsafe for every element, which means, okay, so far my earlier assignment of queens on the board is not going to have to make modifications. So what I do is, I'd recursively go back to the previous row. So previous function call maintains the previous row that we're on. So okay, there was a mistake, which means okay, we have to find new columns. So what I would do is I'd take this queen and remove it from my board and have new safe locations gets freed up. So I would go ahead and continue from this spot. So each recursive function call has a loop that traverses each column. When I find a safe spot, I put a queen down there, and I recursively call next row, but I still maintain the previous row where that queen was last left in. So I know where to continue from if I have to keep working, because we saw from this case there was no row, there was no queens to get put down over here in this row. So I had to try a different spot in this previous row. So now I'm going to go ahead and put a queen down over here instead as next safe location, because these are all unsafe. I go to the next row. I see there's, so I would recursively call this function again from scratch, and I would sort of, starting from column 0, I would basically keep trying every column, but they're all unsafe. So I go back to the previous row, and I see here I already tried every spot in this row, so I have to go back up to the previous row again. So you can see how the recursion is kind of happening. I would recursively go back to the previous row, and I would continue from where I left off in that row. So recursion was nice because it's a very simple way to maintain where I last left off. But of course, you can have a loop and mark, for each row, mark what column you were last on, so you know where to continue from. But that's the whole idea. You have to go back to the previous row and then continue from that row, and then go back if, let's say, there's no valid solution exists. So okay, go back to the previous row. I unmark this spot. I'm going to go ahead and try this location onto the next row. I start from the beginning because I'm doing this new row from scratch, because I did this row earlier but for a different queen in the previous row, because in the previous row I put the queen over here, remember? So now I put the queen over here, so I start all over again on the remaining row. So I'm going to start from the very beginning on this row, put a look at this spot, it's not safe. That spot is safe, so I put a queen down over here. Go to the next row. This is not safe, not safe, not safe. This is safe, put a queen down here. On to the next row. Not safe, and I found a spot here, and man, just barely couldn't do it because the final row there's no safe spot. So let's go back up to the previous row, unmark this spot, no more safe locations. Go back to the previous row, unmark this, and then go and continue from here. Nothing exists that's safe anymore. Go back to the previous row, unmark this, and try this spot now. So I continue where I left off. When I backtrack, go back to the previous row and try to find a new assignment of a queen. So I put a queen over here this time, go to the next row, and yeah, there's no safe locations, so go back to the previous row, no new spot, so I go back to the previous row, unmark this one. Now I'm going to try this spot, because I just tried this, so I'm going to continue from where I left off. I'm going to go to this spot over here, go to the next row, and start all over again, because now I'm going to restart the next row, because in this row I found a new spot for the queen, so I have to start all over again on the next rows from that point on. So anyway, I'm going to try this spot over here, the next row, try this location, next row, I only can pick this location, and again, no luck. So I backtrack, have to backtrack again, no other spots, backtrack. I'm going to try this spot now, and I see, well, no safe locations over here, so go back, no more spots in this row, so I go back again. And then here I try this spot this time around. And I go to the next row, start from scratch. I see the very first entry that's available is this location. Put the spot down and mark all the spots on the board that are unsafe. Go to the next row, the first spot happens to be here. Next row, first spot happens to be here. And again, well, next to this row over here, nothing works, so I have to backtrack, unmark it. Nothing else in this row, so go back to your previous row, unmark it. Nothing else in this row to be processed, so go back to your previous row, unmark this queen location, then try a next spot in this row. So I continue from the last left off spot, put a queen over here, then try a next row all the way from the beginning again, because I'm doing this all over again from scratch, because remember, I put the queen somewhere else in the previous row, so now I have to, do the whole process all over again for this next row. So I start from column 0 again, put a queen over here. Next row, start from the very left position, put a queen here. Nothing works in this row, so I have to go back up, then try the next spot from where I last left off, which will be here. Same problem again. No more locations remaining, so go back to the previous row, unmark this. Nothing else can be done here. Go back to the previous row, unmark this, nowhere else I can go, so go back to the previous row, unmark it, and try from where I left off, try the next spot. And then do the same process again. So what I do essentially is, when I find a location for a queen to be put down the row, I go to the next row, but I still remember the previous row, because I may have to try the next spot afterwards, but I still maintain the location of the queen from the previous row, and I start with the new row. I start from the very beginning. And I only try a new spot if I return back from a previous row, from a lower row, sorry. If I return back and I wasn't able to put a queen in those remaining rows, okay, from where I left off, try the next location. And if I tried every spot there, okay, well then go back to the previous row and have that recursive function pick the next column from where last left off, put a queen down there, and then start all over again on that new row. Quote unquote simple as that. It's actually a backtracking algorithm. It's going to try to find all the possible assignments, not everyone, because obviously if I try every permutation, it would maybe potentially could try to put all 8 queens in this one column, and that's already invalid solution. So it doesn't try every possible solution, but it tries all the progressive solutions. So at some point you may have to go back all the way up to the very second row and try a next spot, and then do the same thing again until eventually the very last row we put a queen down over here, and that means we know we found a solution, so we can do stuff accordingly. So what I did was I had a recursive function. If it returned true, that means the row or rows below, I was able to find a location for a queen, so I returned true. If the recursive function I call onto the next row returns false, that means, okay, given this arrangement, there was no solution, so I'm going to continue from that row and try to find a new position for the queen, and so forth. So whenever you unmark and mark content on the board, here's one potential problem. So let's go ahead and let me try to put a queen over here for right now. Okay, so we see over here, this is going to remain, sort of unsafe, and this is also unsafe. So this part right here is an overlap between these two queens. So in my code I originally wrote was, okay, if I move the queen somewhere else, I want to unmark all the locations so now they're safe, right? So I would unmark all of these as being safe. So if I remove this queen, my algorithm would have actually unmarked this spot also of being safe. But it's not safe because this queen is actually still hitting it. So that means it's still attacking this location right there. So I wouldn't be able to put a queen here, but in my algorithm, it would actually, go ahead and say put a queen here. It would unmark all these spots, even the overlapping spots, and then my algorithm would actually put a queen over here for some reason, and I would think, why is it doing that? But that's because I made a mistake. It was an edge case right there. So you want to make sure if you unmark a spot, only unmark it if no other queen is currently attacking that spot. So I had a struct array I used. And then, sorry, you had an array of structs, a two-dimensional array of structs, and it would have a boolean to mark safe and unsafe, but also had a different value to help me denote, is there another queen also currently attacking that location? Only unmark if there's no other queen attacking. So how do you solve that? Well, I guess you have to think about that, but that's how I approach this problem. So of course, you can have a loop and have multiple variables to maintain the last location of a previous row. But recursively doing it was simpler for me because in a recursive function, when I turn back to the calling function, it knows where to continue from because it was last stuck on one spot, and then it would continue that loop from where last left off. So for me, it was made more sense. But if you want to use like a nested loop to do this, that's all up to you. You have to maintain possibly a lot more variables to maintain all the last locations. So when you go back to the previous row, you don't just simply start from the beginning, you continue from where you last left off. If you enter a row from, for the first time, or if you enter in, let's say over here, when I jump down over here, I always start from the beginning. But if I go back up to a row, I always start from where I last left off in that row. So hopefully this video did help you understand. I didn't want to spend time in class covering this because I wanted to get into the actual 302 content, but hopefully the video did sort of help. So if you have any questions, of course, let me know. And I guess until later on, take care, everybody.